Hello and welcome to R&D Mathematics. Today we are going to talk about determinants of 3 by 3 matrices. So last video we talked about determinants of 2 by 2. Today determinants of 3 by 3. And we will generalize some ideas. First let's take an example and let's say 2, 3, 5, 4, 2, 1. Now, if I do this, that's the matrix, and if I do this, that's the determinant. Now, the determinant of this is given by the easiest way to go, 6. That means this one. So I'm going to use first row. You'll understand this in a minute. 6 is in first row and first column. So when I omit that row and column, the remaining part, the determinant of that 2 by 2 matrix, then minus, why that minus appears, we'll talk about it today, later, 2, that means the second element. Now we do the same thing, so we omit that row and that column, so the remaining one are these. So 2, 5, 4, 1, then plus 3, this guy. So the remaining part is this, 2, 3, 4, 2. Okay, that's how we find determinant. Now remember, this plus minus, that pattern will keep going. If you have a big 4 by 4, 5 by 4 by 4, this is the case, 5 by 5, this, and like that. But again, there's a reasoning behind that. We will talk about that in a minute, but let's find this first. So 6 times, now 2 by 2 you know how to do, 3 into 1 minus 2 into 5, so 3 minus 10, negative 7. So minus 2, 2 into 1 minus 4 into 5, so 2 minus 20, negative 18, plus 3, 2 into 2, 4 minus 12, negative 8. So we get negative 42 plus 36 minus 24. And when you add them, 42, 24, so you have 66 minus 30. That's the determinant. Now, where is this idea coming from? Let's have a look at that now. Minus and cofactors. First, let's talk about minus, this guy. Let's take an example. 1, 2, 1, 3, negative 2, 4, negative 5, 6, say 3, 5, 2. Now this determinant, let's call it M, or let's call it let's call it M. Minor, normally, it's better to call another, let's call it A, O, B, sorry about that. Because minor, the word, let me write down, M11, that means minor of element appears in first row, first column. So this guy, minor of that guy is the determinant of the remaining, when you delete that row and column, the determinant of the remaining part. So that's what you did in our first example. So this is the theory part behind it. So you are going to get negative 10 minus 30, so negative 40. So M12. This time you have to, so this guy 3. So minor of that element 3. First row, second column. This. So you have 4, 6, 3, 2. So you get 4 into 2, 8, minus 18, negative 10, right? Now you don't have to do this crossing all the time. Now you can do it in your mind. Now let me write down this matrix again. So it should be, let me write the same matrix again so it's much clear. 4, negative 5, 6, 3, 5, 2. By the way, how many minors are there? For each element there is a minor. So because of that, there are 9 minors, because our matrix is 3 by 3. Remember, when we are talking about determinants, it's square matrices. So M13, this guy. So 4, negative 5, 3, 5, we get 20 minus 20 minus 15, so you get 4, 35, right? Then M21, so we go with this. So you have to delete again. If you are not used to do, if you are still new to this, you can do this. After a while you can do this in your head. So you just need to isolate that row and column and look at the remaining part. So 3, negative 2, 5, 2, we get 6 minus 10. When there is minus, it's better to write them down again. So you get 16. And let me write down, let me try to see whether I can finish in this. So M22 with this, so the remaining one will be the corner ones, this. So 1, negative 2, 3, 2. So you get 2 minus 6, 8. M23. So M23, second row, third column, this one. So you delete second row and third column. So remaining 1, 3, 3, 5. So 5 minus 9, which is negative 4. And we have found 6 minus 3 more to go. Let me put that in this window somehow. So M31, third row, first column. So you delete third row, first column. So the remaining one is, so when you delete third row and first column, 3, negative 2, 5, negative 5, 6. You get 18 minus plus, so again minus 10, you get 8. M32, you delete third row, second column. So third row, second column, 1, negative 2, 4, 6. So you are getting 6 minus 8, which is 14. Last one, M3, 3. So third row, you delete third row, third column. So 1, 3, 4, negative 5. You get 1, 3, 4. So negative 5 minus 12, negative 17. See, these are the minors. This is across first row, and then here, over here, second row. And I put over here the third row. So there are 9 minors. Now, next, cofactors. So the definition of cofactor we call Cij. Some books call Aij. And by the way, let me go back previous. Minors are denoted by Mij. See, that's what we did. I and j keep changing over number of rows and columns. So M11, 1, 2, see, these are ij. ij's. So Cij is negative 1 raised to r plus c mij. So you already know what this is. That's minor. So minors and cofactors are almost the same. It only is a difference between signs. So for example, minor can be 7 and cofactor can be either 7 or negative 7. Why? Because see, clearly look at this equation. Negative 1 raised to some power, right? So negative 1 raised to even power, that's going to be 1. Negative 1 raised to odd power, that's going to be negative 1. So this part right here will be either plus or minus. So cofactor will almost same as minor with plus and cofactor, as the value you have the minus value, but the sign that will be depending on the position. That is exactly why, let me go back. In the very first example, see this place, you get minus. Now, let's have a clear understanding about this. So, Cij negative 1 raised to r plus c mij. Now, let's take our early example. In our early example, 1, 3, negative 2, that was the matrix. 4, negative 5, 6, and 3, 5, 2. In this one, we found, let me write down the minus m11, m12, m13, m21, m22, m23. We found those values m31, m32, m33, and those values negative 40, we got negative 40, negative 10, m13 we got 35, and the second row we got 16, 8 and negative 4, and then we got 8, 14 and negative 17. Now C11 is negative 1 raised to 1 plus 1, because R is the row number, C for column. So row 1, column 1, 1 plus 1. So even M11. M11 is negative 40, and here negative 1 raised to 2, which is positive 1, so negative 40. You don't change. So C12, here the sign changes. Why? Because negative 1 raised to third power, that will give you a negative. You already have negative, so positive 10. C13, sign does not change, 35. C21, you know what, let's write down it like this. C31, C32 and C33. Here 21. So the, when you have an even, when you add these numbers, if it is even, cofactor and minor are the same, because this part will be 1. So let's find this guy and this guy, and 3 plus 3 6, this guy, same as minus. So C22 is M22 8, C31 is M31 8, C33 is M33 negative 17. This remaining guys, the same value with reversed. So M21 16, so this is negative 16. C23 M23 negative 4, so it's 4. C32 M32 14, so this is negative 14. And we are done, right? Okay, I think you understand that well. Now let's go to our first example. Look at this. Now in this example, now let me erase the simplification part here. what we are doing here, if you observe carefully, first row, first element, so let me call it A11, and this one is cofactor of A11. Or, that's why we use that notation. This is C11. So let me write it clearly again. A11, C11. And look at this. Second one, I can write second one plus 2 times minus 1 times 2, 5, 4, 1, right? So this part, that's the cofactor, because that minus 1, that place is 1, 2 place. Because of that, in our cofactor definition, you have a minus. That's why you have this minus over here. So A12, C12 plus A13, C13. So now we are in a position to write down the definition for 3 by 3 matrix determinant. So if you have, what, A11, A12, A13, A21, A22, A23, A31, A32, A33. Let's call this matrix A. The determinant of A given by A11, C11, A12, C12, A13, C13. Right? Now, this is known as this is actually expanding or expansion across first row. Do you understand this? First row, see, in this equation, we are using A11, A12, and A13. So we are going across this, and we can show that. We are not going to prove them here, but using examples, we can verify it for ourselves. This is true for any row or across any row or any column. For example, second row, A21, C21, A22, C22, A23, C23. Or you can use third row. You don't have to use all the rows, right? You just need to use one row or one column. It will work. How do you use? Let me, without writing, you can write down like that 6 things, because every row and every column will, let me show an example. In this case, it's easy to go with third row because there are so many zeros. 0 into anything will be 0. You just have to go with this thing, right? So that depends on the example. Now, I think that is the theory part. I think that's enough for today. Now, using an example in our next video, I will go through all the rows and all the columns and get into the same result. Let's do this. So how about this exercise? For the next video, -3, 5, -1, 0, 1, 2. The exercise is to find the determinant using whatever the column you like, whatever the row you like. Try to use more than one row or one column. So in the next video, I'll go through this row, this row, this row, and get to the same result. And this column, this column, this column, all 6 different approaches, 6 different equations, but get to the same result. And let me give you the result so you can The result should be 23. Should be 23. Check it. Okay, guys. Thank you.